Hello, welcome. Let's try to solve another Leetcode problem. 2061, number of spaces cleaning, robot cleaned. So for this problem, we are giving a room, and inside it's going to be 0 and 1. So 1 means obstacle. It means the robot can never go to the obstacle. Yeah, but 0, it means the empty space, which means the robot can always go to the spaces according to the specific rule. So the rule is the robot gonna be starting from the position of 0 and 0. This gonna be starting from this position, and it's gonna have a direction of right. Yeah. So this gonna be the first step, and then the robot can go to this direction and go to this direction. So if it go to the border or if it go to obstacles, it will turn 90 degrees clockwise. So it means it's gonna turn down and go down, and there's a border. So it's gonna turn 90 degrees clockwise. So it will turn this direction and this direction. Now it wanted to turn up, but there's obstacles. It means it cannot go up. Yeah. So how many spaces in total? It's gonna be 7. So 7 gonna be our final return. How can we solve this problem? Yeah. So definitely we will not use the DFS or BFS to solve it, because normally it's gonna be 4 directions. Yeah, but the idea is similar to BFS or DFS. It is a search problem, but we can directly use a set to solve the problem. Yeah, so for us, we need to set a set. So the idea of set is we're gonna prepare a set. So we're gonna start from the first position. So for the first position, it's gonna be a 0 and 0. So if it is okay, we're gonna put it into the set. But we need to store another value, because for example this is the room and everything is empty. So this means for the robot it can go this direction, can go down, and can go right, and can go to the top as well. Yeah, so basically means it's gonna have a loop. Yeah, because it's gonna just go this direction, this direction, this direction, and this direction. But how can we stop it? From here we can go up, but if we only use the 2 dimensions like 0 and 0, definitely, yeah, we cannot avoid it. But definitely we need to go to this position. Yeah, because at this position, definitely we don't want to let it go to the right. Yeah. So we still need it to go up. So how can we do that? Yeah, because if we go to the right, definitely the return gonna be 9, but instead of the final return gonna be 8. So this is similar to the third example. Yeah, as we can see, it's gonna be 8 instead of 9. But how can we avoid that? Yeah, so the idea is that we're gonna use the 3 dimensions as our visited set. So basically, we're gonna go to the right, go to the bottom, and go to the left, and then go up. Yeah, but this cell can still be visited. Yeah, only if it go to this direction, it means it cannot go to the further directions. So how can we represent? We're gonna use the 3 dimensions. So it's gonna be 0, 0. This is gonna be x and y position, and we also need to have another variable. It's gonna be the direction. So from the beginning, we're gonna set the direction as a 0. So how many directions? So there are 4 directions. We're gonna use the 0, 1, 2, 3 as our directions. Yeah. Now we just need to use a set to solve the problem. So it's gonna be okay, because we prepared 3 dimensions of the set. So basically, after that, we just need to check the length of the set only for 2 dimensions. We will ignore this, the third one, for checking the final result. Yeah. Now let's just use this idea to solve the problem. So let me just do some preparations. So we're gonna prepare R and C, row and column. It's gonna be length of the room and length of the room 0. Now let me just prepare the directions. So there are gonna be 4 directions. Yeah. So the first direction, it means we're gonna from 0, 0, we're gonna go to the right. So how can we represent it? So it's gonna be 0, 1, and then we're gonna go to the then we're gonna go down. So how can we go down? So it's gonna be if we go down, so the bottom gonna be the same, but the row gonna be 1. Yeah, so it's gonna become 1 0. So this means we can go to the bottom. So how can we go to the left? So definitely it's gonna be 0 -1. And how can we go up? It's gonna be a -1 with a 0. So for the directions, we must design the direction. First, we're gonna go to the right, and then we're gonna go to the bottom, and then left, and then up. So we're gonna make such kind of sequence, and this sequence is really important. Yeah, because this is what the robot just go while it meets obstacles. So we're gonna keep this kind of direction. Now we're gonna prepare a weighted set. It's gonna be an empty set. And let's just prepare 3 variables, x and y gonna be the position, so we're gonna set it 0 and 0, and the direction gonna be starting from 0 as well. Now, we're gonna check the set, so while x, y, and d, so for the first position, and combined with the direction, not inside the weighted set. So what are we gonna do? We just add it inside, so it's gonna be a tuple, x, y, and d. Yeah. Maybe let me just use R and C. R and C and D. R and C just means positions and D just means directions. Yeah. So we're gonna add it inside. Now we're gonna update the row and bottom, row and column. So the new row and new column gonna be R plus dr and C plus DC. So what is dr and DC? So dr and DC is just for directions. It's gonna be the directions with this D. Yeah, so currently it's gonna be this 0 and 1 for the first direction. So 0, 0 plus this one. So it's gonna be the next direction. So for example, it's gonna be from here, goes to the right, goes to the next position, which is gonna be the right direction here. Yeah. Now let's just do a check. So if it is inside the boundary, let's just check the new row and new column. Yeah. And if this is also inside the boundary, and if the room new row and new column for this position, if it is empty, yeah, if it is equal to 0, it means it's going to be empty. So now what are we going to do? We just need to update the R and C, because for the next time we're going to put it inside the, yeah, we're going to put it inside the weighted set. So we're going to update the RC, going to be equal to row and column, and we don't need to change the directions because everything is okay. So for example, from the starting position from here, so from the starting position from here, we can still go to the right. It is okay. So we can still go to the right. Now, what happens for if it goes out of the boundary, or if it meets obstacles? What happens if it goes to this position? So it means it will go to the bottom. This means we're gonna change the direction. But how can we change the direction? So it's gonna be an else tag. Yeah, else. So if it didn't meet the conditions, basically we needed to change the direction. So d gonna equal to d plus 1 modular 4. Yeah. So this means first of all, this d equal to 0. Now we meet a boundary. This means we're gonna change the direction. So 0 plus 1 modular 4. So it's gonna be 1. Yeah. This means it's gonna be the next direction here. Yeah. Now it will go to the next direction here, next direction here. Now what happens if d plus 1? So if it will go back to this position. So this is why d plus 1 modular 4. Yeah. Normally we're gonna use this kind of a formula to solve it. Now what are we gonna do? We're gonna return the length of the weighted set, but currently this weighted set can be too long. So for example, what we are doing for this example, so we're gonna go to the bottom and we go here and we go here. Now for our algorithm, we meet the obstacles, but we will go back because we store 3 variables R, C, and D inside of the tuple. So it means from here we're gonna go up. It's not possible, so we're gonna go to the right. Because the direction is different. Now we're going to go to the right, we're going to go to the right, we're going to go top, and go to the left, and go to the left. So when it goes to here, it cannot go to the right again, because here it has the same direction. So we're gonna stop the while loop. So how many positions? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So this means the length of this weighted set is going to be 13, but actually it's going to be 7. So this means we need to avoid that. So length of the set. So the set going to be yeah, let's just use just use xy for x, y, d inside the weighted set. So we're gonna use this kind of set operation just to avoid the duplicate. Yeah, now let me just run it to have a check. Now as you can see it works. Yeah, but let me just print out what is the weighted set. What is the length of the weighted set? Yeah, so because for the first example it's going to be 13. Yeah. Now as you can see the length of the weighted set is 13, but actually it's going to be 7. So this is why we need to avoid that. Yeah. Now let me just submit it to check if it works. Now as you can see it works and it's pretty fast. So this is just a linear algorithm, but this is a grid. So basically the time complexity going to be r times c, the row times column. So yeah, it's going to be 300 times 300, and we are also using a weighted set. But as there are a direction, so the weighted set is going to be so for the space it's going to be n square times 4, because there are 4 directions. So the space complexity is going to be n square, and the time complexity is going to be n square as well. So n is the length of the grid. Maybe the length and width of the grid is the same, maybe not. It's not. So it is m times n. Yeah. So for the time complexity, it is m times n. For the space complexity, it is 4 times m times n. Yeah. I think that's all about it. Thank you for watching. See you next time.